example, we want to find the point xy that's on the graph of the function y equals x squared, and is closer to the point minus 4, comma 3. So start by drawing a picture of this because this is definitely a geometric type problem. We have the graph of y equals x squared, and the point minus 4, 3. I want to find the point on this graph that's closer to this point, so it should be somewhere around here-ish. But how can I do this quantitatively? So I'm looking for the closest point. Closest tells me I'm minimizing distance. How do we find the distance? Well, that's the distance formula. D is the square root of x1 minus x2 squared plus y1 minus y2 squared. But if we're trying to minimize distance, we could also just minimize distance squared, and that would give the same result. Because if distance is small, distance squared is also small, and it becomes the smallest point that way as well. It won't give us the same actual value for the function, but we'll find the same minimum. We can instead look at d squared, which is x minus x2 squared plus y minus y2 squared for a given point xy. And in this case, we're looking for distance to the point negative 4, comma 3. Means I can replace this by x plus 4 for the minus 4 plus y minus 3 squared. And this still now has two variables in it. How can I reduce this down to one variable? Well, I can use the fact that I know this point must be on the graph of y equals x squared, which means y equals x squared. So I can put that in here, get that my new function d of x is just x plus 4 squared plus x squared minus 3 squared. And now I want to solve a calculus problem, but I don't have an interval yet. What values of x are valid for this problem? Well, I can plug in whatever I want for x. I can go all the way out to minus infinity this way, or all the way out to plus infinity this way. It doesn't matter what I put in for x. Any values work. If you look at the function here, as x gets really big, either positive or negative, and x squared gets really big, positive or negative, this gets really big anyway, so it's not going to be the minimum value. So if I find one critical point inside, I know that is the minimum value that I'm looking for. Let's expand this out and hunt for critical points. I can then differentiate this and look for where this is 0. Now that's a cubic, so I can't really solve it nicely, but I can get a numerical solution. And there is one solution here at x is approximately equal to minus 1.888, which makes sense based on the problem. And so my answer, which is the point xy that's closest, is at minus 1.8868, and then that number squared, which is about 3.56. Let's say we would solve that example using distance.